Good evening, participants. Hope you are doing all well. And uh, so today we are back with this chapter one of application of machine learning algorithms using remote sensing satellite images. And today is the second day. Hope you are enjoying our sessions and learning also with the enjoy the sessions. And I would like to inform you that please do ask your questions in the chat box of YouTube Live. So we will take those questions at the end of this session. And please do not forget to fill the attendance form which is circulated during the training program. So now with this, we can start with today's session. Over to you, Kabiraj sir.
Okay, thank you, Subham. So, good evening to all. Just I'm sharing my screen. Let me know if you're able to see my screen. I hope my screen is visible to all of you.
Yes, sir.
Yeah. So, yesterday we have talked about the GE and remote sensing part, and that is basics how to start with the GE and what are the documents we can read by our own to for self learning. And today we'll be talking about some basic code and with case studies, and then I will show you the practical example of satellite data import and displaying in GE platform. Okay. So here is some of the key things you should know before starting the Earth Engine. So it is basically having the access of remote sensing data of all kinds of physical, or we can say climatology related data, climate data, terrain data, all kinds of data it is having in cloud platform in a single platform. For that, you no need to go here and there. It is there already. You just need to retrieve the data from the cloud, and it is having the analysis power, and it can analyze a huge quantity of data within a fraction of second, and also to visualize them. And finally we can create a web application for those data. So what are the different things we can do? So here I have given some of the samples where we can work out. So the first one is land cover classifications. So using Earth Engine, we can definitely do supervised and unsupervised image classification using different algorithm. So generally, whoever new to the GIS platform, the new user will always use the desktop version of any GIS software such as ArcGIS, QGIS, Iradas Imagine, and then Geomatica, and then Snap. There are various softwares available, which is sometime open source, sometime it is not. So basically, people who are new to this GIS, they are using the desktop version where we need to download the satellite image, and then we need to pre-process, post-process, and then finally do the image classification. So these are the different kinds of analysis we need to do first of all before starting the classification process. So here we no need to do those things. First of all, you no need to download the satellite image. It is already there. And yes, if you want to do some kind of pre-processing or post-processing, that is absolutely you can do. But that is also there in the Earth Engine platform as well. And it is developed by the Google developers. Okay. So using that satellite product, actually we can do the land use classification. So the second one is environmental monitoring. So we can do this environmental monitoring as well. So here we have environment monitoring related data, for example, temperature, precipitations, and then different kind of gaseous related data for using Sentinel-5 P data. So we have different kinds of satellite data as well. So using those satellite data, we can actually monitor the environment in a real time. So how the changes is happen, for example, what is the impact before Diwali, after Diwali, or during the Diwali, like that we can analyze and we can do the case studies. So that also can be done in Earth Engine. The third component is land surface temperature. As all of you are aware about this land surface temperature, how it is day by day increasing. So this is actually kind of urban heat island, which is locally getting uh, heated. Sometimes in urban area, it will be more influential than rural area. So this kind of land surface temperature actually we can predict, or we can calculate through different kind of thermal satellite images. And for example, Landsat image, we have thermal sensors and we can use that for a long period of time. So what was the condition during 90s and afterwards? So 20, then 2020. So what is the changes is happen, and based on the land use land cover, you can actually monitor the land surface temperature changes. So, for example, if a kind of artificial changes is happened, so basically this will happen in urban areas. So maybe agricultural land will convert into built up, or maybe some kind of industrial zone, or forest can be converted into mineral exploration zone, or you can say mining sites. So those areas temperature will suddenly increase after the degradation of the vegetation. So those can be monitored using this land surface temperature. This is actually very helpful, and this land surface temperature also we can include in the environment monitoring assessment. So this can be clubbed together. The fourth component is vegetation indices. So this is a kind of a very important indices, and using this we actually can monitor the vegetation health and the stage of the vegetation. What kind of, like, is it in mature stage, or it is in young, or it is already culture period, or it is already over, or cultivation period, you can say. So those things can be easily monitored using these vegetation indices. So there are a lot number of vegetation indices. If you search in Google, you will get a lot of things. So this is not only NDVI, EVI, or LAI. There are different kinds of vegetation indices also available. You just need to see the formula, and we can write that algorithm, or we can write that formula using Earth Engine code editor. And finally, overall, we can see the G is a powerful tool, or you can say platform, to do different kind of geospatial analysis. And with the vast amount of satellite data available and its powerful analytical capability, it's creating the ability to customize the web applications, and also to publish or to share with the different kind of research group among the research group. So as I have already explained in my previous class, so we can basically use two programming language. One is Java, one is Python. So yesterday, one student asked question about whether we can use the Python. Yes, we can use Python. And here the supported version of Python is 2.7 and 3.6. And you can use the open source Anaconda, and can be used to load, process, analyze geospatial data within the GE. So these things can be integrated, but by default in Earth Engine code editor, it is in JavaScript. So if you know JavaScript, you can directly write the code in code editor itself. And here is a sample code I have given over here. So basically what it shows, it is taking a variable. Variable denotes by var. You can see this is variable which is named under L8TOA. This is Landsat 8, and TOA stands for top of atmosphere. And this variable holds this particular image collections of this entire Landsat series TOA 8-day collections. So this is a 8-day product, and this is basically image collection. So entire image of this particular product is available. So it's not particularly one image, it's a hundred or millions of images is present over in this variable. Now if we print that, So the number of satellite images available on that particular variable, or you can say at a particular collections, will show there in the console section, right? And if you want to see the particular image, so there is a year we need to select. So here, for example, 2014 we have selected, and this is, you can see, is a yearly product. It's 1 year, and this previous one you can see is a 8-day product. So these two are different product, right? And to add this product into map, this is the command, we can say map.add layer. So using this command you can actually add this image to your map layout, right? And you also can select a particular band. So this is the command for selecting a band. So here, like, we have selected band 3, and likewise this we can add in a different way as well. So this is actually RGB, you can see the combination of 3 different band, and we have given the total all bands. So it's a list of bands, so you can see within a bracket we have shown the 3 bands, so it's a list of band. And then we need to tell the earth engine what color you want. So you have to tell the earth engine what color you want. So you can write the color name, or this is actually HTML color code which you can find out through Google. And what will be the maximum minimum also you need to write out. If you don't know, you can go to the inspector and select any pixel, and you will understand what is the minimum and maximum value. And after that, you, if you want, you can rename the image. So here the image is RGB, so we can write here RGB. So this is a kind of showing a satellite image in a true color image. So this entire code belongs to that, right? And the next one is image collection and doing the filtering. So we have a collection of image. In the first code itself, you can see image collection, and the same thing over here repeated again. And then we are writing filter date. So this particular command is by default given by whatever it is appeared in yellow color. These are default command, and it is white color also, it is default command for that particular product. So entire thing is by default, we can't change anything. It's given by Earth Engine developers. Okay, only what we can change is the color code and the minimum maximum value and the variable name, like here name of the image, or variable this variable name we can change, right? But this image collection we can't change. This is given by Earth Engine developer by default. Then print command also we can't change, it is given by Earth Engine developer, so this we have to use it all the time, so we can't modify it. Okay, so here filter date, using this command, actually we are filtering a date between starting and ending date. So here we can see here 2014 6 and 1, and from this date to this date we are actually filtering the date. So whatever images will be available within this two date, those images will be showing into the next console panel if you print it. So if you print like this, it will show the total number of images. Okay, the same way here also image collection dot median. So this is a command through which the entire image collection which will come over here. So for example 20 images, if it comes over here, so 20 images at the same time we can't see it, right? We can't visualize it because at a time, single time, we can see only one image. So to populate all 20 images into a single, we have to use this median. So what this median basically do, this will convert your entire image collection, and within using this algorithm, median is a measures of central tendency. All of you have studied maybe in your graduation. So it will actually create a impact on your image. So what kind of impact? So it will remove the highly reflected pixels and no like very less reflectance pixels. So it will remove the darkest pixel and the brightest pixel, both it will remove, and it will overall give a very good quality of image. So that's what this median function do. So it will take all the 20 images, and within these 20 images, what are the darkest pixels are available, those things it will remove, and then what are the brightest pixels are available, that also it will remove, and then finally it will make an overall images of these 20 satellite images, and it will give you a perfect output where you can see each and everything. So it will give you better output if you use this median. And then this is a algorithm for Landsat for compositing raw image. So if you have 20 different tile, so what it will do, it will composite all the images in a single. So here we can see in the search bar, yesterday I have shown. So here actually we are writing the satellite data product name, and here I have searched the NDVI Landsat 7, and you can see it has populated over here. So here we have Landsat annual, Landsat 7 annual NDVI composite, and then we have Landsat 7 30-day, 32-day Landsat composite, NDVI composite, and similarly 8-day NDVI composite. Likewise, it is having different product. So in that we have selected this product over here, and we can see here the detail of the image collection ID. So this image collection ID will be using further in the code editor, right? So here is the detail about the that particular product. We can see here the detail how the product has been modified, or we can say how they have generated this product, and what are the informations available in this, and the date of availability also we can see over here. And this is a kind of sample image we can see. So this is the color, like this we can see, and what is the minimum maximum value. So those things also we can see through this. Now if you use the NDVI, and if you take 2000 image, 2000 year image, so it's a year of 2000, and this is the two different year image. So one is 2000 and another is 2014. So what is the difference between these two images? So if you check the difference, you want to check the difference, how it has changed. So in 2000 you can see there is some pixels which were previously greenery. You can see here that particularly rounded zone. So here we can see the green images is totally densely populated or densely clustered, and in the 2014 image you can see some pixels were looks in black color, right? So those areas are not now in green color. So what happened to those pixels? So actually maybe cultivation is over, or it is not taking place in that time. So likewise we can monitor the vegetation change. So here itself we can see the changes, right? And if you look into this, here also there is a huge change. So here the water body expanded little bit, right? So likewise each and everything we can remark. So here also we can see there is a change. So previously it was greenery, now you can see there is a black spot over here. So this kind of change detection analysis we can do for a long time period. So here this is around 1 decade we can see. So this is the changes happen between this 2000 and 2014. And in Google Earth Engine docs itself, we have a lot of algorithm and the script given by Google developers. So we can use those things if you are very new to that particular platform. So there are different mathematical operator. So we can see here three different mathematical operator. So the first one is subtract. So this is particularly subtracting an image from another image. So it's basically the mathematical operator like minus. So you are doing subtraction from a particular number. So that is the thing. So divide also the same way, and multiplication also the same thing. So these are the three different mathematical operator. And these are the common for that particular or respective operator. So if you want to subtract from the image, so dot subtract, and in the bracket, in the parenthesis, you need to write the particular image name, right? Same way in case of divide and in the case of multiplications. So these are the three different commands. And if you are not able to remember this, you simply can type over here, and you can see there are different things available over here, and you have to search it, and definitely these things also will be there, right? And we have created a variable called difference. So this variable name you can change, there is nothing issue. So if you change it, anyhow it will run, because variables depends on the user what variable name you want to make. Okay, and this image one, if you consider this image one as a 2000 satellite imagery, NDVI 2000, and if you try to minus or subtract that particular 2014 image, right? So this is actually the change detection kind of thing. So you are doing the subtraction and the changes will appear, right? And you can see here there is a variable collection where we are calling the Landsat 7 32-day NDVI product, right? So this is particular image collection, and in this image collection, maybe there are millions of images, right? As it is a image collection, and then we need to filter this, right? So how we will filter? Now we are calling another variable called filter 2014. So this variable name also you can design according to your suitability, right? And then how you will filter it? So collection dot filter date. So how this collection comes? This collection comes from this variable, right? And what this variable is stored? This variable is stored all the image collection pertaining to this particular product, right? So this variable will come over here where we have stored all the satellite images of this product. And now I am filtering the date using this filter date script, and we are telling this is the start date and ending date. So within this date, I need the satellite image. Now in between these two date also there will be a some kind of like 10 to 15 images, but I need only one image, right? So how to call that particular one image? So for that, we have given another command called dot max. So what it will do? It will take the maximum possible updated image in between these two dates. For example, this is the maximum updated time within this time frame. So this is the updated time, recent one. So it will check which is the recent date, and that particular recent date image it will take. So this is the command for that, right? Again, I am repeating, this is the starting date and this is the ending date, and in between that there will be a 20 or 30 images, right? In that 20 or 30 images we need to select only one image, right? So what we will do, using the dot max function, or you can say dot max command, what it will do, it will take the latest image between these two date range. Okay, and the same way we are doing for 2000 as well. So the same way you can see the collection, and this collection is same only, it is coming from here, this is the collection, and then we are doing the filter date. Again we are putting over here and we are putting the date and taking the updated image, right? And using this subtract function, you can see over here subtract script, here we are finding the difference. So what we are putting here, filter 2000. So here the first image I have written here 2000, and we are subtracting the filter 2014, which is this one, and here we have mentioned 2014, and finally we are getting the difference between these two images. So this will be the variable which will be storing this difference, right? And now I want to add this difference into a map. So what will be the next comment? You can see here map dot add layer and adding the difference, right? See, this is square bracket for curly bracket for this curly bracket is for adding any kind of dictionary. So for example, you want to mention the palette or minimum maximum value, you should write in this inside this curly bracket. Okay, and now you can see this kind of overview will come because we have not defined the colors, right? So inside the curly bracket, we have not defined the color, minimum, maximum value. So by default, it will take the gray color. So you can see what are the that whitest pixel you can see. So these are the highest changes happen, whereas the little darker pixels, or you can say gray pixels, there is a small changes happen, right? And through this example, what we have understood, areas with highest NDVI change. So NDVI denotes to this. NDVI represent normalized different vegetation index, where we are focusing on vegetation cover, okay, in terms of vegetation cover. So after getting the particular difference image, so using this command, we are putting another command. If NDVI 2000 minus NDVI 2014 is greater than 4, then live vegetation was diminished, right? And if NDVI 2000 minus 2014 value, and the difference value, this value is lesser than 0, then live vegetation was added, right? So this is the difference. And now let's define the extensive change greater than 0.5. So greater than 0.5, why greater than 0.5? Because NDVI value above 0.5 is a healthier vegetation. Below this, scrubland will come, scrubland, and then shrubland, like that. The lowest cropland, those things will come. And above this 0.5 is kind of dense vegetation, we can say, or thick vegetation. The leaf will be very thick. So that's why they have given this 0.5, right? And now the same thing we're writing over here through code, right? We can see first we have given this subtract, and then we are creating another variable called diminished, and to find out the difference greater than 0.5, so this is the command, gt is greater than, right? And what it will return? Will returns 1 if the forest value is greater than the second for each matched pair of bands in image 1 and image 2. So let's have a look. So here again the entire code is given over here. So first of all, we have image collection, and then filtering date wise, and then we are finding the difference, and here we are directly adding the greater than 0.5, and finally we are adding to the map, right? So this is for filtered 2014. Filtered 2014 means this one. So this is 2014 image, and this is 2000 image, and then we are adding the difference image. So this is how it will look like. So there will be, at last there will be two values. One will be the true value and 0 will be the negative value, like which is not matching our criteria. So above 0.5 will become 1, and below 0.5 will be 0. So you can see above 0.5, this whitest pixels are above 0.5, right? So here the maximum changes happen during the period. So you can see, if you compare this, so you can see these areas, there is a huge pixels which has changed during this two different period of time. So here also you can see this location and this location, there is a change, and we can see there are a lot of changes happened during this period. So here there is a dense vegetation look over here, and but here it has changed, right? So those things are reflected over here. Next, how you will mask that pixels, right? So masking pixel is an image makes those pixel transparent. Okay, so we'll see what is this transparent mean. So value of 0 or lower, transparent. Above, it will render, right? So we have value of 0 and 1. So that's what it happened in the previous slide. We have seen 0 and 1. So 1 it is showed over here, and 0 it is shown in a black color, right? So a call to mask an image. So this is the command we are using. So image1 dot mask image2, right? And pixels from image2 will be used as the mask of image1. Now any pixel in image2 with a value of 0 will be made transparent in image1. So what it is showing? It is telling that any pixel in image2 with a value of 0. So if we see here, any image in image1, so this is saying image2, which is image2 is our 2014 image is 2. So whatever it is 0 over here, so for example here it is 0, it will appear over here as a 1, right? And it will be made as a transparent. So like that, likewise it will work. Some method is mask the layer with itself and mask difference after that. So how you will, it will mask the difference? So difference already we have, the difference image is already is there. So we have already the difference image. So this is the difference image, and then we are masking the difference. So again you can see this is the code. So first of all, making the difference. So difference is subtracting the two images, and then we are getting the diminished areas which is greater than 0.5 areas, and then we are masking that. So diminished and mask and then diminished, right? So this diminished is this one, and this only we are going to mask again. Okay, so map add layer and you will get this particular thing. So you can see this is the red pixels where the main things changes has taken place. So background, you can see the real satellite images, and these are the areas, red areas where the changes happened, major changes happened, right? And the remaining areas there is minor change, so it has not reflected. So these are actually above the threshold value. So what threshold value we have fixed? 0.5, greater than 0.5. So within that, greater than 0.5, these are the zone where we can identify the changes. So if we would have fixed like 0.3, more number of pixel would have appeared over here, right? But as we have fixed our threshold value above 0.5 or greater than 0.5, so these are the maximum region where the maximum change has taken place, right? So again, you can see the image collection, and then we have two different dates, and we have difference. We have calculated the difference, and likewise. So these are the two images, and this is the changes, right? Now we have calculated all the things. Now the next target is we got our output. Now we need to export that particular image, right? So that question comes into our mind, how to export that particular image, right? So as you can see the images over here, now this particular red pixels, that particular image I want to export, right? So there is two option in Earth Engine. You can see as an asset and as a drive, or the third option is cloud, right? Cloud is not given over here as the cloud is commercial version. So cloud is not given over here. So you can see export image as a asset, as a cloud, and to drive. So likewise it is there, and this task image, task name and parameter, so this will go to the here in the task. So this is actually now will not work actually. So basically we are dealing with this three. So what the each thing will do, this image to asset, once you will export image to the asset section, it will go to here, this asset option inside the Earth Engine. So it will be in cloud only. Anyhow, you are not getting into your local drive. So it will be inside the Earth Engine cloud, okay, in asset option. The second one is the cloud storage. So if you have commercial version with you, so what you can do, you can use this particular to cloud storage, and it will store in cloud. And to drive, this particular option will export this entire image into the Google Drive, right? So once you use this, and the export will happen in the taskbar. Here we have task, and this entire image will be exported to your particularly that named folder inside the Google Drive. Okay. So you can see this is the thing, and this is the panel. I have already explained you about this. So first one is pan. Pan is to actually move the layer or move the map layer. And the second one is point, where you can actually digitize or you can point, like create a point feature. And the third one is the line, and the fourth one is a polygon. And after that there will be a rectangle option, which is not showed over here. So here you can see I've created a rectangle or polygon, we can say. And after the creation of this polygon, you can see there will be a layer, and by default it will come as a geometry, variable name geometry, where you will get the each vertices information. So each vertices lat long will be available in this, right? So now this is a kind of region of interest you are creating. Okay. So region of interest can be created before starting the analysis or after getting the output. If you want to take only the major changes area, so in that case you can create after the analysis. So there are different kinds of analysis, and according to that you have to select your region of interest. And now define the name of the variable. So you can see now the geometry has been changed to AOI, that is area of interest, right? So variable name we can change according to our perception. And after that, here we can see export image to drive, right? So what is the command for that? So this is the entire command we have to write. So the first one will be image, and the entire things will come in between one the parenthesis, between the parenthesis you can see the, and then as this entire things is a dictionary, so this entire thing will come under curly bracket, you can see here. So the first one will be image. So here we have to name the image, which already we got it over here. It can be diminished, or it can be difference, or whatever layer you want to export. And then the second one is description of that image. So this can be anything according to your view, you can write. And then file name prefix, this also according to your perception you can write. Then region of interest, this will be the variable which we have created just now using the drawing function. So here we have drawn a rectangle, so that variable name will come over here. It can be region of interest, it can be geometry, it can be anything according to the variable name. And the third one is scale. So this is particularly resolution kind of thing. So what is the pixel size you want? So that only you have to write over here. Okay. So as you have used the here Landsat 7, so all Landsat series maximum cases we will get 30-meter resolution. So it's taken as a 30. So by default, Earth Engine entire functions will run on meter. So it is in meter actually. The unit won't be available over here. So it is by default in meter. Okay. So you can see here after writing the code in the taskbar, you can see there is a task called diminished vegetation, right? And the things will appear something like this. So you have to click on this run, and this run will take you into this picture. So it will again whatever things you have written previously, those things will populate over here. So you have written vegetation name, and there should not be any space. So here you can see no spaces. So you have to modify. Either you can put underscore, otherwise it will give an error. And we have given a resolution of 30 meter. You can see meter per pixel. Here we can see the unit, right? So this is a 30-meter resolution image. And then we have three different options, right? And this first one is to drive, that is Google Drive. The second one is cloud storage, which we need to buy for the commercial version. And the third one is asset option, that is Earth Engine Asset, EE Asset. So these three things available to export a particular feature, or you can say image. Okay, both in the both the cases it will come something like this. Okay, but in the case of vector image, or you can say shape file or kind of things, KML, those things resolution won't come. Okay, and then you have to name the drive folder where you want to save it inside Google Drive. And here you need to write the folder name, and finally you need to write the file name. See, this task name is coming from here, and this file name will go into your Google Drive. With this name only you will get the file in your Google Drive, inside your Google Drive. Okay, and after getting the layer, you can see something like this, where you can see only 1 is available, 0 is not there. So the only changes taken place, those pixels only is highlighted over here, only the area of change, major change greater than 0.5. So we have created a threshold limit greater than 0.5, so those pixels only highlighted over here. Okay, and here we can see the base map of world imagery, which is taken from ESRI base map, right? Now coming to the next is next export option called asset, and in that case you need to click over here. The remaining options will be the same, but here the user ID you need to define. So inside the asset you will have a user ID. So you need to see where you need to save, or you can create a separate user ID, asset ID inside the user. So asset ID you need to create, and then you need to name your particular output figures. Okay, and this is the thing. So by default there will be a mean and median, maximum, so like that. Here also it's there, but in our case, since it's a one image, so if it is a collection of image, you can take that way. And then after that we need to run here, and you can see here. So after the export things, see here, you can see the task got completed. Over here you can see the tick. So there will be a right tick over in the corner, right corner. And after that you can see here the ID, the asset ID, and the respective image will show something like this, and the property, dimension, and the date, size. So these are the information will be available. So this is some kind of masking layer and populating into the map. Okay, so they have masked it, and palette they put in red, and that only showed over here. Thank you. Any questions? If you have any questions or doubt, you can ask.
Thank you very much, sir. I think we have some questions. The first question is, if I put less value like 0.3 or 0.4, then get more red color, and if I put 0.6 or 0.9, less red color appears on image. If is it so?
Yeah, correct. So more the threshold value, you will get the less number of pixels, because what will happen, the mature trees which are having highly dense vegetable, those dense vegetable will get reflected on above or greater than 0.5. But if you do the threshold value or threshold limit greater than 0.3, then some kind of shrubland, cropland, those things also will take place. So in that case, number of pixel will increase.
Thank you very much, sir. Second question is, can I export our selected area of interest?
Yeah, we can do it after drawing that particular rectangle as I have shown in my PPT. So there will create a area of interest variable, or you can rename it region of interest or whatever it is. And after that, while exporting, there will be option called area or region. There we need to put that particular variable name, and it will only take that particular region of interest satellite image, or we can say the output, anything, whatever you want to export.
Okay, so in continuation with this, there is a question: when I am exporting big area, image is image it shows error.
Yeah, for big area, it's like in Earth Engine, we can see there is a limitation of pixels in open source version, or we can say that local user, not in commercial version. So for example, people like researcher or a student or whoever using directly using like account, by creating an account in Earth Engine, those users will only able to export up to a certain limit of pixel, for example 3 million or 6 million, something like that. So beyond that you won't able to get the particular image. Okay, so if it is crossing the pixel limit, beyond that it will give an error. So what you have to do in that case, just increase the scale size. So in that case, you just need to increase the scale size. For example, in my PPT, I have shown you 30-meter, right? There you just put 60-meter, and definitely it will get exported.
Thank you very much, sir. There is one more question: what is difference between NDVI and EVI, and which is preferable?
See, it depends on the research or area of environment, everything you need to consider. Okay. So for example, enhanced vegetation index is the modified one better than NDVI? So we can definitely use EVI instead of NDVI, but again, we have to see the environment where we are working and the kind of satellite image we are using. So all the things we need to consider, and then only we need to decide whether we'll use NDVI or EVI, or in certain cases, researcher used to like use both the vegetation indices.
Thank you very much, sir. There is one more question. If we use mosaic instead of median, what is mosaic?
See, mosaic means you are taking the 4 to 5 tiles of different geospatial, or you can say different location, right? So, for example, your region of interest covering 4 tiles of satellite image. Now, doing mosaicing, you are actually merging all the 4 tiles and making a single tile, right? That is a mosaicing. But median is something different. Median is a particular satellite image. You are giving an image collection of you are defining a date, so start date and end date of the satellite image. Now within that start and end date, we are getting 20 number of tiles. Okay, that 20 number of tiles belongs to the same location, not different location. In mosaicing, that 4 tiles will be different location, and finally we are mosaicing it, so you are making a single image. But in the case of median, what we are doing, we are getting 20 satellite images of same region, and now we are doing median to remove the darkest pixel and brightest pixel to get a better output. Okay.
Okay, thank you very much, sir. Sir, if there is one more question, if I increase pixel of that image segment value, will the pixel be affected?
So you are asking about greater than 0.5, the same question, right?
Yes, sir. It's the same question.
So in that case, already as I have answered in the previous question, so if you increase or decrease the threshold value, it will behave accordingly. So for example, if you are reducing the threshold value, the number of pixel will increase, because here we are giving the lesser threshold value, because of that the number of change will be more. So number of changes pixel will be more. If you are putting greater than 0.5, the pixel will be less.
Thank you very much, sir. The next question is, which will be more appropriate to use, ArcGIS or any other tool?
So, for example, here we are dealing with Google Earth Engine, and we are not talking about ArcGIS or Eredas or something like that. But it is always preferable to use open source satellite image if you don't have license.
Thank you very much, sir. I think we are done with today's question and today's class. Thank you very much, sir, once again.
Thank you, Saurabh. Suvankar.
So, participants, please do not forget to fill the attendance form, which is shared with you in the chat box of YouTube Live. And stay tuned. We will meet tomorrow at same time. Sir, there is one more question with the continuation of the same previous one. You said that increase to 60. You said, sir, increase 30 to 60.
30 to 60. Okay,
Yeah.
that is called spatial resolution of the satellite, or the spatial resolution of a particular raster image. We are talking about raster image. It can be satellite image, it can be anything. We are talking about raster image where we will have a multiple number of or millions of pixels, right? So what I am talking, you just increase the pixel size, and so that your number of pixel will reduce. So for example, if you are putting 30-meter spatial resolution, if your entire region of interest is like covering around 2 million, 200 millions of pixels, if you the same region of interest using that pixel alone, if you increase the size 60, so it will reduce drastically. The number of pixel will reduce drastically. So you can actually export it. So that error won't come. Okay.
Yes, sir. Thank you very much, sir.
Okay. Thank you.
So we are closing today's class here. And please do not forget to fill the attendance form, which is shared in the YouTube live chat box. Thank you.